Hey guys, how's it going? So today I'm going to show you how to do a cool flip simulation like this that has a pretty tough to do flip simulation with complex collisions. So by default, a simulation like this would be pretty difficult just out of the box. Trying to follow the bottle, it would give you a really hard time. And so today I'm showing you a workflow that tries to get around this collision difficulty by actually using matrices and the orient attribute to help make this process easier. It's a fun project that I hope you enjoy and it helps you out in your project. And so it's a little bit complicated, but if you stick with me, we'll be able to get through it together. And I really hope this helps your workflow. Alright, so let's get started and make a model here. I'm going to go into front view, X, red, we're going to go set. And we will delete this guy. Hide that. We're gonna say that this is the bottle. And we're gonna go from here. So we created the bottle. Now we're gonna make a RBD sim of the bottle. And packet RBD sim default. Make sure that this is set to 1. And give it a little bit of a twist, something like this. Okay, maybe something like that. That, cool. That is correct. We're going to unpack it. We're going to get back all of its attributes. I'm going to do a file cache, save. We're going to save that out. We're going to make sure it's clamped. We're going to do a time shift on it and a clip. We're going to just like define the water level here. Let's say it's like here, and then we're going to do a poly cap with points from volume. Give it something like that. And then we'll do a flip sim. We'll make sure that this is connected to this. And we just want to view this. Add ID, just in case. Cut that guy off. And now we have that. I'm going to add a static object. We're going to make sure it's the first one. This is going to be the bottle. And the way I want to go about doing this is poly extrude, give it back, and then I'm actually going to make a collision. I don't think, yeah, no, I don't have a collision, so sims, here I'm going to make here I'm going to make a collision, add category, we're going to put that into sops. Put this into sims, and then in here we're going to add a collision source like this. geo. This whole thing is going to be called collision source. We're going to copy it. And so now, there we go. So now we have that. We're going to put this into here. We're going to take this P. There's our, makes sense. So this is going to be the bottle. And all that's fine and dandy. Okay, so now we have the collision. And we have the source here. And now we just need the transform. So this is going to extract the transform and give me the matrix. I want the full transform. And all I'm going to do to make sure this works is I'm going to grab, this is a matrix. So to make sure that it follows the animation, we're going to grab the transform on the first point, and then we're going to multiply that by the matrix. And so now it should follow the bottle animation. So if I look at this, there it is. It is following the bottle animation, which is exactly what we want. But now what we need is we need a way to apply gravity to the bottle. So the way we're going to do that is I'm actually going to just duplicate this, and instead of we're just going to do this so that we can get orient. First off, let me go ahead and call this orient, if I can spell orient. And we need a way, either I can do it here, let me go ahead and just set it up. So inside of here, we're going to do, on the particle velocity, we're going to set up a point pop vop. We're going to input in this orient data. We're going to grab that data using this. You have to make sure it's 0 in the point num. And it is not, it is a orient. And we just need to do a Q invert. So this is something that I struggled with for a while. I finally figured it out. We just need to Q invert this. Gravity is negative 9.8. And all we have to do is Q rotate this by the inverse of the orientation of the bottle. And this will give us the correct gravity. So if you look at it now, when it goes to rotate and such, it's going to be more or less correct. Now, we also have to make sure that it's not sourcing every single frame, so we're going to say this. You can either do it that way, or you can do this with solve on creation. And now this is correct. So this should be correct. So if I go back in here and we template this, it should let me color by velocity. Maybe make that like that. We should see the water more or less moving with the bottle correctly. And the gravity should be more or less correct. And that's how you make an animation with a moving bottle. Okay, so now what we want to do is, we got the rolling animation working. We want to make it so that when the liquid exits from the bottle, it correctly will leak out correctly. So the way we're going to do that, so this works for now, but whenever it goes to leak out, it tends to be problematic. So I changed a few things here. I just changed, instead of directly plugging it into the force, we're putting it into gravity. And so all you gotta do now is just say force is equal to gravity, and that fixes that. And so now it should just roll through. There it is. And you can see that the liquid is exiting from the bottle and it's still swirling around. But this swirling motion is because it's exiting the bottle and it's still rotating around the bottle's pivot. So we don't want that. The bottle is correct, but we need a way to define, okay, how is it exiting the bottle? And pretty much all I did to change this animation was I just rotated it a bit more, 360. And so yeah, now it's really rocking it. It's really going for it. So we want to make it so that, like I said, when it exits the bottle, it does something different. So the way we're gonna do that is everything's still the same. Force is gravity. So we need a way to define if it's in the bottle or outside. So the way I'm going to do that is with the SOP solver. Fine. And okay, and then what we're going to do is we're going to grab the bottle. We're going to grab that bottle, and we're going to grab the first frame like this, and we're just going to group based on if it's inside or outside the bottle. Now this isn't working because it's being dumb, so we're just gonna say object, and I already know from experience that the water gets very close to the edge and sometimes gets too close to the edge to want to leak out. So we want to prevent leakage, so into the wrong group. So we're just going to peak this a little bit. And we're going to make this like that, or maybe more like that. So now we have a group, and it's going to replace, so it's going to constantly change this group. And what we want to do to make it a lot easier for volume's sake, we're going to make an attribute. So here, I'm going to say bottle, and we're going to say bottle is equal to 1, meaning it's in the bottle. And then if we're not in the bottle, we're going to say 0. Now if we don't do this node, and we only do this node, the moment it's 1, it's never going to go back to 0. Because everything's 1 at first. So in this case, we want to say if it exits the bottle, it's not in bottle. We could say out of bottle, so we could, but just for my sake, just to make sure that I'm doing this tutorial correctly, we're going to do it like this because this is how I remember to do it. So we've defined our attribute, and now what we want to do is actually count this. So, and I'll explain why later. But we want to make a count so that every frame that the liquid leaves the bottle, there's a count. So it's going to be 0, 1, 2, 3, 4. Because basically what we want to do is we want to kind of like a just born group for when it leaves the bottle. We want to say, hey, if I only want you to apply something on 1 frame. So here we've defined the bottle attributes and group. Here we've defined gravity. And here we've said force is gravity. Now what we can do is we can say not bottle, and then for bottle, if it's in the bottle we want to apply this. If it's not in the bottle, then we just want to say 8, 0. So gravity is 9.8. Cool. So now when it leaves, gravity is just going to be -1. Okay, that's a start, but you can see that it's still colliding with the edge of the bottle like this. We don't want that. So in order to fix this, we need to tell it, hey, well, for one, we need to grab this matrix attribute. So we're going to do that with this guy. So we're going to do pop wrangle. We're going to grab this. We're going to say m is equal to 0.1 transform. And there we go. We've grabbed that matrix attribute. And now what we want to say is, this is fine, but here's where that count comes in. So we're going to say if the count is less than or equal to 1, meaning 0 over 1, we want to apply that matrix. So what that's going to do is that's going to say, hey, the moment it leaves the bottle, I want you to put it exactly where that bottle is in space. So it's moving in space, and here we just want to say bottle. So this is getting better. We still need to fix that collision behavior because that's not correct. We want to get rid of these guys, but we can do that later. But to get rid of the collision behavior, all you need to do is tell it. You actually have to do a few things, and in my experimentation, this is what I had to do. So the way collisions work in Flip is it's actually a volume and a particle. So in order to ignore collisions in particles, so it's called collision ignore, and you just type in the string that you want to ignore. So this is part of it. This is useless because there is no collision attribute, but it's going to ignore the bottle, and as you can see, it's not ignoring it, it's still there. And that's because this isn't the only thing you have to do. So there's a few things you need to do. For one, I'm going to move this up, but the main thing that you need to do is a gas field wrangle. So collisions, you can tell by looking inside of here. If you do this and then say in collision processing, you can see that all this stuff, all the collisions, is actually volume. These are microsolvers, so this is all volume-based collisions. So if we say collision is 0, you'll see it actually starts to work a little bit better. It's not perfect. Where's that section of code where this one. You can see it's not ignoring bottle, it's not ignoring the ground plane. If we actually say, let's say star, it's going to ignore all the collisions. This is ignoring all the collisions. So if you just have this, it doesn't do anything, right? That actually looks pretty cool. So if we just have this, it doesn't do anything. If we just have this, it also doesn't do everything. We need both in order to ignore the collisions. Now we don't want to ignore the ground plane, so we just want to type in bottle here. So we're going to ignore the bottle, and we're going to set collision to 0. Now we need a way to define how it's ignoring the collision. So for this, it's pretty easy. So if it's not in the bottle, we want to ignore that collision behavior. We want to ignore that. So that's easy enough. For the wrangle, it's a little bit more complicated. So for the wrangle, I'm going to use my tool here. So for the wrangle, we don't need any of this, but we do want it's an int. We're going to call this bottle. We're going to say 1, and then we're going to say 1, and we don't want P, we want bottle. And so what we're trying to do here is you can actually get particle information from DOPS. And the other way you could do this is with a match field, but I couldn't get this working in the short amount of time that I was experimenting with it. So we're just gonna do what I know works. So in a wrangle, you can get nearby points from that voxel. So just like every point in space has a position, every voxel has a position. Anyway, if we get the bottle, we say if it's equal to 0, then the collision is 0. So what we're saying is if it's in the bottle, if it's out of the bottle, collision is 0. Now how do we define what is this 1? Well, that's the first input, this guy. Not this one, this one. And we need DOP data. Now, DOP data works by looking at, you need to type in what data. So in this case, flip object. So we're going to say flip object 1, and that is the particles. You could also say geometry to get the particles themselves, to make sure you're just getting the particles. Collision is 0, and don't do that. So there we go. So now it's not going to be colliding with the bottle, and it's going to be moved to that location with this matrix here. And so let's see what this looks. Now we need to do something kind of well, we already have that bottle. Bottle is here, so we don't need that. And the reason this is acting weird is because we need to get rid of the scene view. And there we go. And let's actually get rid of these. We don't need these. And there we go. So now, awesome. So now we have a really nice bottle simulation. It leaks out well, and it's colliding well. So as a review, this was a longer tutorial, but as a review, what we did was we made velocity and angular velocity to make it spin and kind of hit the ground and spill out this way. We extracted the transform at both as a matrix and an orient. Ignore this, we do not need this. We grabbed that orient information. So inside of here, we grabbed that transform information, and we used that later to apply it to the particles that just left the bottle on that first frame. The way we defined the bottle, if it's in or out, is we grouped the particles based on just a normal group. We peeked the bottle out a tiny bit to make sure that it encapsulates all the particles in there. If it's in the bottle, we said bottle is 1. If it's outside of the bottle, we said bottle is 0. And we gave it a count. Gravity, this is what we've already done, where we took the orientation of the bottle, negative 9.8, goes into gravity. And this is so that we can modify the force later if we need to, which in our case we did. If it's in the bottle, force is equal to gravity. If it's not in the bottle, then force is equal to the regular gravity, negative 9.8 and y. And if the count is less than or equal, again, if it just leaves the bottle, it's going to start counting. So if the count is less than or equal to 1, then we want to apply that matrix attribute to it so that it rotates it and places it where it needs to be. This is the only way I found to do correct collisions. Or sorry, to correctly, because before I was trying to rotate the ground plane and it was a no, you just don't do that. Here we are saying if it exits the bottle, we're gonna ignore the bottle collision, and that works for the particles, but we need more than that, because while this works for the particles, it's not going to work for the volume. So for the volume, you need a way to find the nearest points for each voxel. We're grabbing those points, and we're just doing 1 point. This radius determines like how far out it looks, so you want it to be relatively small. So in this case, we're saying if the bottle is 0, meaning it left the bottle, then collision is 0. There's also another collision weight. You can also set that to 0 if you want. And the way you look at that is with the collision weights, it tells you that's actually a vector field, data type vector field. So we actually need to say V. And collision is a scalar field. So that's how I knew just to do at collision. You can also say F at collision, since scalars float. That's what that means. So you can also do that if you want. And we just said 1 point because there's no reason to have it look through several points. And that's about it. We can also modify the velocity of this, so we can tell it, hey, because it looks like it's actually squirting out of it like this, which is strange, right? We could tell it to modify the velocity amplitude by 0.3 so that it's not shooting out as much, maybe. Yeah, that actually helps a lot. So that way it just kind of leaks out and it doesn't shoot upward. Or what we could do is just do this. We can say if the then 0 so if the count and if basically if it's shooting upward, then just crank that velocity down. Make sure it's not shooting up in space, because that's going to look weird. Okay, that's better, because we wanted to shoot it from the side but not upwards. And that looks better. Anyway, I hope this tutorial is very helpful to you, and have a good day.